Hello, my name is Umair Afzal, and I'll be going over the fifth FRQ in 2008 BC questions. First question. We are given the x equals 3 critical point, and we're asked to determine if f has a relative max or minimum. So I make a number line and put 0 on it because there is a domain that's given. Then I put a critical point. On the top, I'm going to decide what f of prime is doing, and on the bottom I'm going to show what f is doing. So f prime is the quantity x minus 3 e to the x. If we test 2, for example, we get a negative, and anything larger than 3 is a positive. So that's what f prime is doing, which means that f of x is decreasing on the interval 0 to 3 and increasing from 3 to infinity. So now we just write down what we said. F prime is less than 0 for 0 to 3, and f prime is greater than 0 for x greater than 3. And that means f of x has a relative minimum or a local minimum at x equals 3. This question was worth a total of 2 points, one for finding the minimum and one for the justification. So the next thing we are trying to find where f is decreasing and both concave up. We actually already did the first part because we know that f is decreasing when f is less than 3, but we'll go through it anyway. So we need to find f double prime with product rule, and I can see from that double prime is 0 only at x equals 2. So I made a stacked number line. There's f prime on top and f double prime on the bottom, and I already know what f prime should look like. Now f double prime, if x is 1, I get a negative. If it's greater than 2, I always get a positive. So now we're just going to write that out so that f prime is less than 0 between 0 and 3, and f double prime is greater than 0 for x greater than 2. Well, that means f of x is decreasing and concave up between 2 and 3. This question was worth a total of 3 points, 2 for finding double prime of x, and 1 for answer with reason. And finally, I'm asked to find f of 3. I'm going to rewrite the fundamental theorem. I'm going to do an indefinite integral here. It's going to require integration by part. So you usually want to pick u so that derivatives will go away eventually. And you pick dv so that you can integrate it. So uv minus the integral of v du. So f of 1 is given as 7, and we're just going to add to it the total change in the function between 1 and 3. So now it's just a matter of evaluating this. And so you plug in the numbers and you get 7 minus e to the third plus e times e plus 3 times e. This question was worth 4 points, 1 for using initial condition, 2 for using integration by part, and 1 for the answer.